Hi everyone, and thank you for joining me today. Can I have my slides up there? Yep, thank you. So the topic that I'm going to talk about today is how we can automate the setup of our Angular libraries by using a little bit of help by the Angular CLI, ng-add, and also a really cool library built by the Angular team called Schematics. My name is Stanimira Vlaeva. Okay. I'm a software engineer at Progress. I also work on a really cool open source project called NativeScript, and I'm a GD for Angular and web technologies. The best way to find me on Twitter is by writing my full name. You can also find me anywhere on the social medias, and I'm also always very happy to chat with anyone about schematics or stupid old movies and things like that, so please reach out. Actually, there is a slight change here. Since 2 days ago, I'm now a developer advocate and not a software engineer, and as you can see, I'm already lazy to build slides. I guess that's what I'm supposed to. Okay, that's not how I'm supposed to do it, but I'll get there. So I'm a developer now. So what is NativeScript? First, a short introduction why I'm actually talking about schematics. NativeScript is a framework for building native mobile applications for Android and iOS by using kind of web technologies like JavaScript, Vue, or you can also as well use Angular, of course. And because NativeScript is super well integrated with Angular, you can actually build web apps and mobile apps from the same code base, and you can reuse a huge part of your business logic. So if you have an existing web application built with Angular today, you can add NativeScript to it and convert that to a mobile application. But let's try to do that. Let's follow the steps and try to convert the web app to a native mobile app. First, you need to install NativeScript Angular. This is a package from npm. Then you have to install the webpack plugin for NativeScript. Then you have to update the package.json file to add some NativeScript specific keys. Then you have to update the Angular.json file to add some NativeScript specific keys. Then you have to add a new TypeScript configuration for NativeScript. Then a new entry module, that's the main TS file. Then you need a new root eng module, that's the app module file. And then you need a new bootstrap component, and so on, and so on, and so on. And this list goes on forever. And if you had to do that, it is quite mundane and tedious task. So our goal in NativeScript was to allow all developers that have Angular apps already built to be able to convert their apps to mobile and web apps with as much work as possible. And this is why we use the ng-add, the capabilities of the Angular CLI, to allow every Angular developer to be able to get started with NativeScript. What is the idea? You execute a single command, ng-add NativeScript schematics, and what happens when you do that? First, NativeScript schematics gets installed. This is the package. And then some project transformations gets executed as well. And these project transformations are actually defined inside the package. And this is essentially how it looks like. So we run npm install, we create several files, then we update several files. And these are exactly the same steps that you had to do manually before that. But now they're just getting done for you. And these project transformations that are defined inside that package are actually written with a library called Schematics. And I'm going to call them project transformations from now on in this lecture, because there's this term schematics that shows up everywhere when we talk about the schematics library. So the specific transformation is going to be a project transformation. And schematics is a project transformations tool for scaffolding, updating files, executing different tasks. If we look at that again, we have creating files, the scaffolding part. We have updated files, the modified part. And we also have a task, the npm install, that is being executed. And actually, the ng-generate command is another command inside the Angular CLI that uses schematics under the hood. Again, we have scaffolding, updating, and other things that happen. So all these actions are defined inside the Angular CLI, or more specifically, a different package that the Angular CLI uses for generating services, components, modules, and all that. And we have different collections. The default one that the Angular CLI uses is called @schematic/Angular. This is the npm package containing the project transformations for generating new Angular projects, components, and all that. Of course, there are other collections. There are schematics for NGRX that allow you to generate NGRX-specific things in your projects. And another example that I already mentioned are the schematics for NativeScript. So there are plenty of collections out there now. I think there has been almost 2 years since schematics is out in the wild, so you can definitely find many, many collections. And we will see in a second why this is important. What are the cool things about schematics and why I like using it and recommend you to use it as well? The first thing is atomic updates. Let's see an example without schematics. If you wanted to do some modification to this project without using schematics, but using, for example, some bash script. First, let's say that you want to modify the package.json. You want to add a new dependency. And this is exactly what happens. The package.json is modified. Then you say, in this transformation, I want to create a new file. But here you will naturally get an error because this file already exists. And at this point, the package.json is modified. And unless you have some rollback mechanism, it will stay modified. So this transformation didn't run as a transaction, but instead you have half of the changes and the other half didn't happen. And this is bad because at this state, your project might be broken. And it's not very deterministic. And you have to take care of rollback yourself. If you're using schematics, schematics under the hood doesn't work directly on the file system, but it tries to apply the changes first on a virtual file system. And if everything goes well, then it actually applies all the changes as a transaction to the file system. So we try to modify the package.json. This is one action. Then we try to create a new file. This is a second action. At this point, schematics tries to apply these actions to a representation of the file system instead of the actual file system. We get an error that this is not possible, and schematics actually fails the whole transaction, the whole modification. And our project is in its initial state, which is what is kind of the desired behavior in this case. So this is for the atomic updates provided by schematics. The second thing is that the schematics are composable. All these collections that I mentioned, you can use them in your own schematic collections. So you can install the Angular schematics and reuse the component schematic and just add your specific bits to it. Also, the schematics are quite easy to test. We're not going to show this today because obviously we don't have time for testing. And the final thing is that you write them with TypeScript and they're declarative. This is pretty important. There's no JSON weird configuration that you have to do, and they're also makes them super easy to debug. But let's get started by showing some actual examples. The easiest way to get started is by installing the Schematics CLI. Of course, you can use schematics and execute them through the Angular CLI, but the Schematics CLI is really easy to use and to get started with. In order to create a new collection, you can use, again, the Schematics CLI. The schematics keyword comes from it. Blank is the name of the project transformation that will be executed, which means that this is the new collection template. And then you have to provide the name for your collection. And you will get a bunch of files, obviously. Of course, you have the normal package.json tsconfig stuff, and the rest of it is the actual code for this collection. We have the collection.json, which contains information about every project transformation, and then we have the actual project transformation. We have just one in the beginning called my collection, and we have two files, the test file in the spec and the index file. And in the package.json, the most important thing that you have to notice is the schematics key, which points to the collection.json file. And you definitely need that key if you want to make your package or this collection ng-addable and also recognized by the Angular CLI. So this is something you shouldn't forget, because I forget it all the time, that's why I insist on it. You have to point to the collection.json file. And the collection.json file contains information about every project transformation, as I said. We have just one of them that has a name myCollection. It has a description which describes that this is a blank schematic, and we have some factory which points to a file, and more specifically to something exported by that file. So it points to myCollection index, then we have the hashtag symbol, and myCollection is the part which is the exported function or symbol from that file. So let's take a look at this file. We have an exported function which returns something called a row, and this row is apparently another function which returns a tree. So this is kind of weird, isn't it? We have a function returning a function. Let's start with some basic schematics theory in order to understand that code well. The most important term in the schematics world is tree. So the first part of the tree is the base. This is the representation of the file system at this current moment, or more specifically, the part of the file system where we are executing this command. And we also have different actions. These are the modifications that will be applied to the base. And then later on, these actions will be applied to the actual file system as well. And a rule is a function that takes a tree and returns another tree. The idea is that you will do some modifications to the base, register them as actions automatically, and then these actions will be applied to the base. So we have a function that takes a tree and returns another tree. Then we have a rule factory, which is a function which returns a rule, which essentially means that we have a function which returns a function which takes a tree and which returns a tree. Okay, it's gonna get better, don't worry. I'm kidding, it's not gonna get better. Cool, so function returning a function. This is why it's a factory. This is where the factory keyword came from in the collection.json file. So now we see it. We have the inner function, the rule, and then we have the rule factory. And this is the thing that we should point to in the collection.json, the factory. Okay, now that we know what is that thing we saw, how do we start developing that? Well, we need to run npm install because we have certain dependencies, such as TypeScript apparently. And then we need to run the TypeScript compiler. Usually I just run it in watch mode and I can develop and it automatically fails. So how do we execute stuff in schematics? With the schematics CLI. This is the easiest way for me at least. And then we need to specify the name of the collection, which in this case is the dot, because we are gonna try to execute it just in the current project, and our project is actually the collection itself. Then we have a colon, and we need to specify also the name of the project transformation. And as we saw in the beginning, this scaffolded collection has just a single transformation called myCollection. So again, left of the colon, the name of the collection, right of the colon, the name of the transformation. And when we execute that, we don't get anything, because as we saw, the function that we had initially just takes a tree and returns the same tree. So there are no actual actions to be executed. Let's start doing stuff. Logging, very important, because I don't debug with anything else other than console logs. Logging is very important. And we also will learn how to add options to our schematics, which is more important than logging usually. Of course, we have to register our transformation inside the collection.json. So we add a new property here, logging. This is going to be the name of the transformation, some sample description, and of course, we point to the factory function. What we have here, the outer function, the factory function, can take options. So they're actually a parameter of the rule factory. And the inner function, the actual row can take 3, and it can also take a context. And the context contains a logger. So with context.logger.info, we can log stuff out there. We can also use context.logger.error or warn or more useful debug. Very simple. And how do we do that? Okay, let's see how it works. So we have the schematic CLI, we have our collection, and we have to say logging. We get here undefined because we haven't provided an option. How do we provide an option? By providing it through the CLI. So I can say Tel Aviv, and it's going to say hello Tel Aviv. Simple as that. It's the same in the Angular CLI, or at least similar. The difference is that in the Angular CLI, for example, if you type ng generate component, you can specify the name like that and say my component or whatever, but you also have positional parameters. So you can skip -- name and you can provide something here. And this is going to be the name option. How do we create files? A bit more useful content. We're getting there. We're getting there. Tree.create is the way to create files. You have to specify the path to the file, and the second argument is the stringified content of the file. So when you execute that, the file will be created, and it's going to contain the content you specified. How do we rename and move files? With tree.rename. We should specify the path, the actual path, as the first argument, and the second argument is the new path. So when we execute, it gets renamed. And of course, if it's a path that is in a different directory, the file will be moved. We covered the basics, and now we are going to jump to the actual cool stuff about schematics, which is first composition, templating, modifying files, and also unit testing. But as I said, we don't have time for testing, so probably going to skip that. Well, definitely going to skip that. You can add it later. I'm sure you won't, but still. Composing schematics, the actual powerful thing about schematics. You need to import the schematic thing from the schematics library. And what is the schematic thing? Well, it's a rule factory. And just as a reminder, this is a function which returns a function, which means that, yeah, the rule is also a function. So not complicated. So we have a rule factory, and we can use it. And by executing it, we're going to get a rule back. And because our actual rule factory needs to return a rule, we need to execute schematics. I'm sorry for being so... I mean, I didn't write the library. Okay, so we need to execute schematic. We need to provide the name of the external schematic that we need to use, and we can also specify options. This is basically the JavaScript API for executing schematics. And logging should be registered inside our collection. If we want to use external schematic from a different collection, there's another rule factory that we can also import from Angular Dev Kit schematics. It's called external schematic. And the API is the same for using it. We need to specify the name of the collection, then the name of the project transformation, and then we can provide options as well. So, but this is not really composition, is it? We're just using different schematic from our own schematic. So to compose things, we need to use the chain rule factory. The chain rule factory is another useful function provided by Angular Dev Kit schematics, and it allows us to chain rules one after the other. So in this case, I'm using an external logging rule, and then I'm using my own rule. So we have two functions that are chained together. And if I try to execute that, we're gonna log something on the console, and then we're gonna create a file. So this is how you can chain different project transformations. How do we do templating? First, let's take a look at the actual template. In this case, we have a single file, called underscore file name underscore, and this is for a reason. So the file name here that is between the underscores, it's a parameter. So when we provide this by using the template, it's going to be replaced with an actual file name. And inside the file name, we have content interpolation and also content evaluation. So we can write if statements, and we can also replace city. And city in this case, as you can see, is also a parameter that can be provided. This is how the template looks like. And in order to use the template, we gotta write something like that. And my initial reaction when I saw that was, I mean, it looks kind of complicated, doesn't it? So let's go back to the theory. We already know about factories and rules, but there are also sources. And source, as you see, we have rule, we have source. You see the difference. The source is something that creates, returns a tree, but doesn't have a base. And we also have source factories, which is a function that takes nothing, or it can also take some things, and returns another function, the source. It's lovely. And in the end, we have tree with actions. Let's see an actual example. For example, URL, this function provided by the schematics library, is a source factory. So we can pass in a path in the file system. It takes this path and it creates a tree out of it. And the idea here is that we don't have a base, but the files inside are registered as actions. So we can do some modifications to these files and then later on apply them to the file system somewhere. Or more specifically, we can just dump them somewhere that we don't care about the files that exist there. And this is the previous code refactored. So we have the URL source. We have the URL, which is a source factory. We execute that by providing the path that we want to take as a template, and we get the source, the URL source. Then we have some templating options. These are the things that we want to replace inside the template, and we get the template rule by using the template factory and providing it with these options. Then we get the template source by applying the rule to the URL source, which means that we have some source, we have some files, and we're gonna apply our rules to it. And out of a template, we're gonna get actual files in the end, which are interpolated and replaced. And finally, we use merge with, and this is the most magical part. What do we merge with? Like, what do we merge with? We merge with the tree that we have in this function. So we have a tree, and we merge with it. And this was the trickiest part for me to get. Like, we have merge with a function which takes a single argument, and I didn't have any idea what I'm merging with at this point. But the idea is that we have the tree, the file system that we're executing on, and we merge that file system with the template source, which is already replaced. And when we execute that, we will get a file. And it's important here to notice that the debug option should be set to false when we're using the schematic CLI. Otherwise, we won't apply any changes to the file system. Okay, but enough about that. The final thing that we're going to see is how we can edit files with schematics. And I'm going to show you that, if it works today. Okay, so first of all, let's take a look at the collection.json file. I already have the schematics done because I have prepared just in case I fail with the live coding. So the name of the schematic is add dependency, and the factory is inside editing /index.js, and I have add dependency. This is gonna be the name of the function. So you can open up that, and we have add dependency. So let's start from scratch by removing everything. We have a tree, we have our context, and the idea is to open up the package.json file and add a new dependency. And the dependency is basically specified in the arguments provided to the schematic. So we have the name and the version of the dependency that we want to add. First of all, we need the path to the package.json. And I'm going to assume that it will always execute this in the root of the project. And this means that the package.json is just here. Then we need to read the file. And the way to do that with schematics is by using tree.read and providing the path that we want to read. And this will actually return a buffer, not a string. And it may return undefined if this file doesn't exist. So we need to check that. And if it doesn't exist, I want to throw an error because I don't want to do anything if the package.json doesn't exist. The recommended exception to use in schematics is within a function called schematics exception. And as a message, I can just say file at path package does not exist. Package.json path does not exist. Awesome. I have the buffer. I want to convert it to a string. So content as string is going to look like that. And then because this is a JSON file, I actually, I'm going to need the actual object. So I need to parse the content. As object, it's going to be json.parse content as string. Okay, does anyone see a problem here with this line of code? Anyone? Come on. It can fail, apparently. So I gotta surround that in a try catch and handle the error. So I can log some message by using the logger inside the context. And I can say failed to parse package.json path. And then it's probably a good idea to rethrow the original error as well. And of course, this should be outside because I want to use it after that. So we have content as object. Cool. We already have our package.json as object. So now we can just add the new dependency. And I'm going to ignore the case if we have already that dependency. So I can just say object content as object. What was the name? Where was the name? It's in options. So I'm going to fetch the name and the version from options. And then I can use them there. So I'm setting a new key in the package.json, and this key, the value is the actual version. Cool. How do I save my file? First, I need to convert it back to JSON. To string. So new content. It's gonna be json.stringify content as object. And in this case, I'm gonna ignore the original indentation. And this is something that you should actually think about when you're modifying package.json and JSON files in general. Well, because you have the string, you convert that to object, then you modify that, convert that to string again, and you completely ignore the original indentation of the file. So this is another problem that I'm not going to talk about today, but just be mindful when working with JSON files. Okay, we have the new content, and we want to save that. In order to do that is by registering a new action in the tree, and this can be done by using tree.override. I need to specify the path of the file. So I have the package.json file, and then the new content as string. And finally, of course, I need to return the tree. So this is my function. Let's try if it works. So the name of the schematic, once again, was add dependency. So in order to execute it, yeah. Yes, you're completely right. Because I modified, yeah, okay. Yeah, yeah, yeah. This was different thing. But yeah, I need to modify the dependencies array instead of the whole package JSON. Cool, let's try to execute that. And this time I'll actually try to transpile it as well. When I do this demo, sometimes I don't transpile the file and everything works because it's the old version of the file. So let's try to execute it now. A dependency name will be Tel Aviv, just in case. And the version is gonna be 5.0. The package JSON, it says that it's modified, but if we take a look, it's not actually modified. And once again, very important, using the schematic CLI, you have to specify that you're not in debug mode in order to apply these changes to the file system. And if we take a look at the package JSON now, we have Tel Aviv 5. Cool, it worked. Thank you. Some additional resources, you can find them there. And yeah, you can find them in the slides. The slides are available here. Thank you for attending the session.